and get started with recording. So we did 3.2. We started this slide. We did this example. Y'all did these practice problems. And then we stopped here, right? We're now on these examples. Or did we do these examples in class? Can anyone double check with me if we work these out? Mic check, mic check. Can you guys hear me?
I don't think so. We did
I can
practice
hear you.
too.
We did the practice problem. Okay, we did practice too. Okay, so yeah, we're here now. An example. I'm gonna go ahead and give you guys about a minute to set this up into your notebook. All right. Solve the equations. Excuse me. Excuse me. Sorry about that. Example, solve the equations, check your solution. And then we have two examples. We have example A and example B. A is 8x minus 9x equals 12 minus 17. The first thing I'm gonna go ahead and do, that was my timer class. I'm gonna go ahead and move forward. So the first thing you wanna do is you always wanna draw a line down the equal sign. For me, that line represents the barrier, the boundary of what happens on one side that we must do to the other side. Now, before we can manipulate this equation and move things around, we have to simplify the left side and have to simplify the right side. Now, when I say simplify, a way to simplify is either PEMDAS or CLT, where CLT stands for combining like terms. Now, if you take a look at example A, do I have any like terms on the right side, class?
You have 8x and 9x.
What's 8x minus 9x? What's 8 take away
Negative
9?
1.
Negative 1x. Excellent. Equals. Now, do I have any like terms on the right side, class?
12 and 17, sir.
Yeah. You have $12 and spent 17. What do you owe the bank?
-5.
That's correct. Now, remember, the goal is we want to get what letter by itself?
The X.
So what's happening with the x and the negative 1?
You have to do the opposite.
And right now,
Divide.
divide. And what we do to one side, we have to do to the other. So these cancel out. So now x is now by itself. A -5 divided by a -1 is a +5, and we are done. Now recall that we do have to check this work out just to make sure that we are on track. So let me go ahead and get this new color. So check. So check is you plug in the answer to the original equation. So we're gonna get 8 times 5 minus 9 times 5 equals question mark 12 minus 17. Now, to make sure the 5 is the correct solution, we must get a true statement from this checking portion. Well, 8 times 5 is 40, minus 9 times 5 is 45, equals, we know 12 take away 17 is -5. 40 take away 45 is -5 as well. -5 equals -5 is a true statement, therefore confirming that 5 is the correct solution. Are there any questions on the steps that I took to, or we took to get the solution or to check? Any questions? All right, if y'all think of any, you can tap them up in the chat or just unmute and ask. Now I'm gonna go ahead and draw a line down the equal sign class. So again. Now, there's no like terms on the right side, right? So I could bring down the 10x just alone. Now, on the left-hand side, what property can we use or should we use to simplify this expression over here?
Distribution.
Distribution. Now, to avoid issues and avoid mistakes, make sure you draw arrows to denote distribution. It's a fail-safe way to avoid making mistakes. Well, 3 times 3x is just 9x. 3 times -5 is -15. Now, keep in mind, class, that our goal is to get x alone on B. So now there's more than one way we can solve this and still get the same answer. And now it's very important that some steps may take longer than the other steps. It's up to you to kind of like get comfortable with how to manipulate this. Now, class, if I wanted to put x's on one side, what can I move over to isolate the letters on one side and the numbers on the other side? Now, keep in mind that the letter doesn't always have to be in the left. It can also be at the right side. So what are your thoughts, class? Well, how would you move x's to one side?
For me, I'd move the 9x to the right side because they're
Well,
like
By
terms.
dividing.
So how do we move 9x? Do we divide 9x or do we subtract? Do we add?
We
Divide.
would divide.
Divide. So now, are you sure we'll divide? What's happening? Is 9x being multiplied to 15?
Oh, hold on. No, you'd actually add it because it's the opposite of subtraction, right?
And what is 9 being subtracted or negative?
Say that again?
Because you said that we will add it, right? If I put a plus 9x, is that gonna cancel this
Get
9x?
subtracted.
Nah, you're
We
not.
have-
You're actually gonna
Oh,
subtract
we're
it.
gonna subtract it. Yeah, see how the manipulation works? Is we have to try it out to see if it cancels out. If we divide it by 9x, we will still get 1. So nothing would have been moving. So we do have to subtract it, okay? So this cancels out, bring down the -15 equals 10x minus 9x is just 1x or just x. X equals -15. This is the same thing as x equals -15, and we're done. And now we just have to check. So then we get 3 parentheses -15 minus 5 equals 10 times -15 question mark equals -150 on the right side. 3 times -15 is -45. -45 minus 5 is -50. 3 times -50 is -150, which equals the same thing here, which is true. So this is the correct solution. What questions may we have on the steps that we took to solve or to check, if any?
Thing that confuses me a little bit is how come you subtract exactly?
Why we subtracted?
Yeah.
Well, look, remember that we can change the order around. So if I wanted to rewrite 9x minus 15, that is the same thing as saying equal to -15 plus 9x. At
Oh,
that point,
okay.
we know that we're plusing the 9x because 9x is positive here, but we never put a positive sign because we don't need it.
That makes
So
sense.
if we flip it, it'll be like this. At this point, we know we're adding the 9x. And what's the opposite of adding 9x? Subtract.
Subtraction.
So if it was written this way, you'd be able to tell what step to do right away. But here, 9x was in front of it. So now we know if it's first, we can just subtract it if it's positive. If it was negative 9x, then we would add it. Does that make better sense?
Enough.
Justin?
Yep.
Good.
Yep.
All right,
Sir,
guys.
your -15 kind of looks like like a 45 in the parentheses.
And the parentheses.
In
Yes,
the check area.
in the check. I do see that. I do see that. You know, we're not all perfect, but we try. I try. All right, better. All right, class.
Thank you, sir.
No, you're good. You're good. You're good. I have OCD too for certain things, so I feel you. All right, class. Ready for your first set of practice for today? Here's practice 1 and practice 2, based off of the examples we just did. I'll call this practice A and practice B. I'm gonna go ahead and give you guys 3 minutes to work these out. Now add more time if needed. Good luck. And I was just using my phone to show students steps how to find the Zoom link. A student texted me he couldn't find the Zoom. Guys, yeah, do you got any potential solutions for A or B, guys? Yeah, want to share? Or does anyone need more time?
I got -4 for B.
X equals -4. Cool. Anyone agree for X equals -4 for B? Anyone for A, guys? These are practice problems, not examples, so I'm not gonna be just giving you the answers. Need you guys to tell me what you think.
Maybe A.
Go for it.
I got like 14 equals Y, but I'm not sure if that's correct.
Okay. Anyone agree or disagree with the 14 or -4? No one agrees or disagrees with these two guys? All right. For the sake of time, I will let you know they are both correct, class. So if you got these two on your own, good job. If not, then you need to go to tutoring and show them these problems and see where you got your mistake. Or speak now and ask me about it. Anyone not get 14 and -4?
I didn't. Would you be able to go over it by chance?
Which one, sir?
Both, if that's okay?
All right, well, this is the practice, so I'm gonna have you do it actually, but I will work
Sure.
outright. So on A, Justin, when you draw the line, can we simplify the left side, sir?
You can. Yeah, you can.
How?
By subtracting -4 by -4, that cancels out.
Whoa. How do you subtract that? We're simplifying, sir. When we simplify,
shit.
what do we do when we simplify, sir?
You do the no, you
Not the
don't do
opposite. It's
Yeah.
done. COT is the
You
acronym.
divide,
What COT stand for?
combine like terms. There we go.
Do we have any? So if you don't know that, then after this line, this equation,
Yeah.
guessing you want to write COT, sir. That way you know
course.
what you need to do. So combine like terms. What's the left side?
-4 and +10 that are like terms.
So how do we combine -4? And why did you say +10, sir? What's in front of the 10 here?
Or hold on, -10.
So what's -4 minus 10?
That was, I had gotten. Oops. I'd gotten +6.
So if you owe the bank $4 and you spend 10 more, you have $6.
Yeah, that's why I'd gotten.
Why?
Isn't it -6?
I'm gonna say the situation one more time, Justin, as a bank.
-14.
You -4. Do you have money in the bank or do you owe money?
You owe.
You owe -10. Are you spending or adding money into your account?
Say that again?
With the -10, are we adding 10 into our account or are we spending
You're
10?
adding.
We're adding.
You're spending.
Do you,
Okay.
do you see that, Justin?
Yes.
So are we adding or are we spending?
We're adding.
Why? Why do you say adding, sir?
Mentioned where we got 10 that's going into the bank, I heard.
So you're telling me when you see a minusing?
No,
we
wait,
think
yeah.
We're adding? Are
No,
you
you're
do you see
taking
the
money out of the bank.
We're taking money out, but we
So you're
already
going
owe-
further negative.
we're going further negative. So what's, if we owe 4 and we go further negative $10 more, what do we owe?
You owe. Hold on. Hold on, give me just a moment. You're subtracting. You owe -6 more, right?
So you're telling me the whole, from owing 4 and we spend 10 more, we only owe 6?
Oh, wait a minute. No, I see what I did.
Someone else said it, Ishmael, what did you
You
say?
owe -14.
There you go, we owe -14.
That's what I did wrong.
You need to be careful with what you write and what you do, okay?
Of course.
From there, the right side, do we have any like terms on the right side, Justin?
4y and 5y. And there you would subtract.
Good, so make it into a story. Do we have 4 or owe 4?
You have 4.
Do we spend 5 or add 5?
Say again.
Do we spend 5 or add 5?
Well, you spend 5. Yeah, you spend
So if
5.
you have 4 and you spend 5, you have 4, you spend 5, what do you
Oh,
have?
no, yeah. You're spending 5,
So
which you get
what will be left over?
negative.
Negative
that?
what? Negative what?
Negative 1.
What should
Negative
we
1
have?
y.
There you go, sir. Is the
I
y
got
by
that.
itself?
So then you divide it by itself because they're both even negatives. That's how you got the positive 14.
So what do I divide by, sir?
You divide by negative 14
Y divide by negative 14.
because you're simplifying it.
What are we simplifying?
God dang it, I'm using. You have to excuse me. My brain's kind of still coming in, but you're simplifying the solution.
Yes, sir. But remember, how do we simplify the solution? What is the objective of solving an equation?
Say again.
What is the objective of finding the solution?
You're finding the total.
No, sir. Anyone want to help out, Justin? What do we do when solving an equation? What's the goal?
Try to take y by itself.
Yeah, y by itself.
Yeah, that.
So what's happening with y and negative 1? They're being what?
Divided.
No, they're not being divided. What is happening with negative 1 and y? When you have a number next to a letter, they're being what?
Simplified.
No, sir. It's an operation.
It's an
Multiplied.
operation. Yeah.
Multiplication. And the opposite of multiplication is,
Division.
and then divide both sides by negative 1.
Yep.
And then right there, y is by itself. And then negative 14 over negative 1. 2 negatives make a what?
Positive.
There we go. Now for B, I'm sorry because of time, I'm not going to be able to go over B, Justin.
That's
but
fine.
I do recommend you putting a star by it and having this be a problem. You go over the tutors, okay? All right, we have another.
Can I
set
say
of-
something, sir?
Go ahead, Ishmael.
B should be exactly the same operation as the example B.
Thank you for your tip.
Sir, did you catch that?
Say that one more time.
Oh, I said practice B should be the same operation as example B.
Ah, yes, yeah, exactly. Yeah, you're right. So pretty much, if you followed the example before this, Justin, it's the same concept as this. Did you catch that, Justin?
Yeah.
All right, let's go ahead and move on to the next set of examples. I'll give you 1 minute. It's very important that you're double checking your math, the little math, because one wrong operation, if you add when you're supposed to subtract, if you divide when you're supposed to multiply, you're supposed to be very careful with that's why I showed you how to check your solutions. And from the sounds of it, when students say, I got this, but I don't know if it's right, at that point, I can say you haven't checked it yet. This example doesn't want us to check it, but you can always check your equations. All right. Take a look at the first example here, example A to the left, the 2x minus 16. Now, our goal here, remember, is the same as always, is to manipulate this to get x alone. So now we want to move the -6 over to get the x variable term alone. So the opposite of -6 is +6. And then what we do to one side, we do to the other. So this goes away. The 2x comes down. 18 plus 6 is 24. Now, remember, a number and variable are being multiplied when they're next to each other. So the opposite of multiplication is division. And what we do to one side, we must do to the other. The twos cancel out. So then I get x equals 12. And we're done. Now, remember to check, you just plug in this to the equation. So it'll be 2 times x, right? 2 times 12 is 24. Take away 6 is 18. So it does work out. So that's one way to do it. All right, let's go ahead and take a look here on the left-hand side. Now, before I actually go back to this one, the right-hand side one, the B. Now look at back to the A. Remember the last example I simplified by combining like terms. Are there any like terms on the left side or the right side?
No.
No, there isn't. That's why I was able to start manipulating. Is that the same leisure we have in this example here in B?
No.
Right. We have to simplify, class. Now look at the left-hand side. Do I have any like terms in the left side?
2 minus 6.
Yeah, which is what? What's 2 minus 6?
I got -4.
That is correct. Thank you, sir. Bring down the equal sign. Now, how do I simplify the right side? What property can we apply?
Distribution?
Yeah, how many arrows am I gonna draw?
Yeah. There we go, just 2.
So it'll be 2 arrows. -5 times x is what?
I got -5x. Well, bring it down.
One second, guys. I have a student texting me. He can't get access to this. It's a new link.
No worries.
Alright. Right, you guys join through the Zoom link on Canvas, right? That's how you guys join every morning.
Yeah, on the
Yeah.
Zoom section.
The Zoom section. And then press join.
Okay. All right. Now when we distribute, we multiply. -5 times x is -5x. -5 times 4 is a -20.
-20.
Good. Bring down the -39. Now, before I can manipulate this and move things around, is there any numbers I can combine on the right side?
20 and 39.
Yeah,
Negative.
yeah. What's -20 minus 39?
-59.
Yeah, -59. It's like you owed 20, but you're like, hey, I need to spend 39 more for gas, and here we are. So now we want to get x by itself. Now, if you're okay solving it like this with x on the right, perfect. If you want to flip it, move the x over here, you can flip that too. You just have to make sure what you're comfortable with. Now remember, our objective is to get x alone. So what am I going to move over first on with where the x is at? The -5 or the -59?
The -59,
Yeah, what's the opposite of -59?
+59.
Positive 59. So that cancels out. So then we get -5x equals. You owe the bank 4 and you had the positive 59. So you're gonna have 55 for yourself. And then we're gonna go ahead and divide both sides by -5. So x gives us -11.
I got 11.
11 or -11?
Negative.
Good. Okay, just making sure, sir. All right, and then plug it in your head here. -11 plus 4 is -7. -7 times -5 is positive 35. 35 minus 39 is -4, which is the left side, and we're good. So any questions on the steps that we took here, guys, for A or B? Any questions whatsoever?
No.
All right, let's see how you guys do on the practice problems. Good luck. I'm gonna go ahead and give you guys 3 minutes. Remember to see the steps that I took in the examples. My practice problems tend to be similar to the examples. That way you can try the process out on your own. Always double check the math. Like when you do a step, double check the step. Okay, I added 5 on both sides. That's good. I subtracted 2 on both sides. That's good. I combined these and got this. That's good, you know? You do not have to be a calculator. You can focus on, you can use a tool. And feel free to ask for help or for ask for questions.
For the first one, I got y=3, and then the second one I got -15.
Anyone agree or disagree with these solutions?
The first one I agree, but the second one I haven't finished yet.
Okay. We'll go. Would you like an extra minute on the timer? Or 2?
Yes, please.
1 or 2?
2.
All right.
I agree with B.
Excellent. 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 Anyone have any question on any of the steps? These are both correct. Last call. Any questions on any of the steps, class?
Can you do A?
Yes, I can. So take a look at A. All right. So order is objective for A. We want to get what by itself?
A Y.
The y, right? So draw the line down the equal sign. So what can we move first before we touch the y term or the variable term? What's the extra baggage there?
Would you do like the opposite of +2?
That is correct. What's the opposite of +2?
-2?
That's correct. What we do to one side, we do to the
Other.
cancels out, bring down the 5y. What's 17 take away 2?
15.
Correct. Now, what's happening with 5 and y? What's operation there that we do not see?
Sorry, say that. Oh, multiplication.
Good. And now what's the opposite of multiplying?
Dividing.
We're gonna divide. What are we gonna divide by to get the y by itself?
Would you divide by 5?
Yeah, and remember, what we do to one side, we have to do it to the,
Other.
and then what's 15 divided by 5?
3.
And y equals 3.
All right. Oh, okay. I see where I messed up.
Okay, good. You see, you're good?
Thank you.
Anytime. Anyone need help with B before I move on, class? All right, let's move on. Recall translating word phrases into expressions. You don't have to draw this box again, just because you are gonna have to write another box in this presentation. We've done this before, but remember to have access to it in your journal. Remember where it's at. And then example 9, I'm gonna go ahead and give you all 3 minutes to set up this example. Now the chart that's there, you do have it before. If you want to take a picture of it again, you can to have it on your phone or screenshot it to have it a shot of it on your computer. So that's telling us that every operation in mathematics, addition, subtraction, multiplication, division, they have different key phrases or words that allows it to transition to that operation. And in example 9, it wants us to write each phrase as an algebraic expression, and they want us to use X to represent a number. I'll wait for the timer to finish before I get on it. Now, when I write an expression class, just an expression, will I see it an equal sign in an expression? Yes or no? And why?
No.
Why not? Why or why not?
You're not solving for X. You're
Exactly.
not equal.
Good. We're not solving for X. And the only math thing that we solve is equations. So remember, that's the key difference from an expression to an equation is the equal sign. just because the student sent me a picture of the practice problems from these and they had equal signs and I had to clarify that. So write each phrase as an algebraic expression, use X to represent a number. So there's examples here to kind of review over the writing from English to math, right? So let's take a look at A. A number, remember, this is the example, so I'm gonna take charge of it. A number, we can call a number X, right? So that's a number increased by, we know increased by is addition by -5, parentheses -5. But remember, in mathematics, we don't really add negative numbers. Adding negative numbers is just the same thing as what operation, guys? Who remembers?
Subtraction.
Subtraction. We're just subtracting this. So A is actually going to be resolved to this. Could you leave this? You could, but it could be confusing for others. So I like to simplify. I think simplifying is courteous. Look at B, the product of -7 and a number. So we know product is multiplication. So I'm going to multiply -7 with X. So -7X. Do I have to put the dot for multiply? I do not, because remember the implication, we know if a number is next to a letter, they are being multiplied. Could I add one? Yes, I could. Let's move on to C. A number less 20. A number, which is X, less 20. And that's it. D, the quotient of -18 in a number. Remember that the first thing after the word of is the top, and then after the and is the bottom. So it's going to be -18 over X. And we're done with D. E. E is the trickiest one. Do not get thrown off by it. It says a number subtracted from -2. So class, is that asking us to do X minus -2? Or is it wanting us to do -2 minus X? A number is being subtracted from what number? We know X is being subtracted.
-2 minus X.
Excellent. Good. Good. What questions do we have on the steps that I took on solving these examples? Any questions at all? All right. Then here is the practice problem class. I'm gonna go ahead and give you all 3 minutes just because there is a lot of words to write on this one. Good luck.
Sir, would C be like 3x if it's 3 times the number?
That is correct, sir.
Okay.
Great question. All right, does anyone need more time, class, before I move on or talk about this? All right, what'd y'all get for A, class? Anyone wanna share what they got for A?
I
Yeah.
I
got
got -3 plus 6.
-3 plus 6 for A, sir? Remember, what should we be using for the phrase a number?
X.
X.
Did I say 6? Oh, I meant, oh yeah. I
You
think I
did-
did say,
You did say 6, but I'm pretty sure you have
oh,
X too.
my
I'm
my
sure-
bad.
No, you're good, dude. Don't trust me. I've made some silly mistakes before. The worst part is they were on tests. So you're
I don't even know
good.
where I got 6 from. I mean, 6.
That's funny. All right, cool. Anyone want to try B out?
I got X minus 5.
I agree.
Ooh, X minus 5. Okay.
Wait.
No. Negative x minus 5.
Negative
What?
X
No.
minus 5. Okay.
Negative.
Let's read it again. What is it asking us? What is it saying? It's saying that -5 decreased
Decreased by
by a number. If something's being decreased by, then they're being what? Subtracted. Right?
subtracted.
What's being subtracted though?
The X.
Yeah, the X is being subtracted. What's the
So
starting?
it's not, so
What do we start with though? What's
negative
being
5.
what's being decreased by a number? What's being decreased by X? -5. There you go.
Oh, so it's not the other way around?
No. The key word. So when it says by, you keep the order the same. You keep the first thing, and then the second thing will be right here. Now,
Okay.
the D is the one that you're talking about. Because the keyword is what?
From.
From.
Oh, okay.
So let's look at C. So make a little note for that, right? Write a star for B and D to know the difference. Because you are going to see these problems on the homework assignment online and on the exam. So y'all need to know the difference from by a number and then from that number. So let's look at C, 3 times the number. I'm just gonna write it because someone already shared it earlier. It's the same thing as 3x. What about D now? A number subtracted from 83. Anyone?
A number of 86, 83 minus X.
There you go.
Where the fuck is 6 from?
Dude, that's kind of crazy. It's funny. Is that your favorite number or something?
I don't even know. It just slips out sometimes.
And this happened twice. All right, E, the quotient of a number and -4. I had a couple students get it wrong last class yesterday, so
X divided by -4.
excellent. Good. Everyone good with E? Just because I had a few students get that wrong. A lot of students were doing 4 over X and X over 4. These are the answers that I was getting yesterday. So they were not it. So everyone good with E?
Yes.
Good. I believe it, Justin. All right, let's move on. All right, now we're gonna go ahead and write an expression, but it's get a little bit more complicated now. Example 9 had simple expressions. Now it's gonna be a little more complex. I'm gonna give you 3 minutes to write this example just because there's a lot of words. I recommend to start on it if you do have time after the 3 minutes.
These are kind of tricky.
Yes, they are. So yeah, to take it in steps, all right? Timer's about to go off, so we'll get started in just a moment. So look at, read it over twice and fours. Whenever you start seeing a, give me a second. Okay. A, read it over. Twice a number, comma, increased by -9. So we can say that twice a number and then that comma is being grouped. The comma separates things. So this is a different part of the expression, and this is gonna be a different part. And this is what's happening at the end after that part, okay? So let's talk about the first part. Twice a number. When we twice any number, that's just multiplying by 2, right?
2, so 2x.
2x, yeah, exactly, 2x. But what's happening right after the 2x though?
It's
-9.
Yeah, it does minus right at the end.
Put a parentheses over the negative
It would,
9.
it would be, but increased by is what original operation though? What's increased by originally? Plus, right? But we're adding by -9, which mathematically is the same crap, is the same shit as subtracting, right? Let me not do equal sign, but an arrow. It's the same thing as 2x minus 9. Everyone agree with me on that part?
Yep.
All right, let's look at B.
Wait, I have a question. Sorry.
No, don't apologize for your questions. Go ahead.
Why don't we write the positive sign if it's increased?
So mathematically, Sophia, so English wise, I could tell you, hey, Sophia, let's say you were my employee, I was the manager, right? And I was like, hey, Sophia, I'm gonna give you a raise of -$2, okay? Well, raise, you think that your hourly number is gonna get higher, right? But the moment that you hear I'm gonna increase your raise by -$2, at that point, are you really, are you gonna really get paid more?
No.
No, I'm really telling you what, when I'm gonna give you a -$2 raise.
That you're decreasing it.
But English wise, I could still tell you that I'm gonna give you a raise of $2, right? Of -$2, I could tell you that technically, right? Just like they could technically say you're gonna increase this value by -9. You as the student need to be like, oh, well, if they want us to increase by this -9, that's not really increasing. So that's why you start off with this first part over here. Sophia, you start off with the 2x plus a -9. But just like you said before, we're not really adding it because it's as a negative number. At the end, it ends up being just subtracting.
Oh, okay.
The point of this is you need to understand that anytime an increase by a negative is just the same shit as subtracting, pretty much. That's the key here. You with me?
Okay. That makes sense. Yeah. Thank you.
Excellent, guys. No, thank you for your question. Like these were very tricky for me, class, because I was not a good English student. Like English is my weakness. I hate writing. I hate, I don't like it. But now I like these examples because it kind of combines the two worlds, right? So look at B. 3 times the difference of a number and 11. So 3 times. So I'm gonna break it down. So 3 is the first part, right? So what should be first in B? 3, right?
3x.
Wow. Does it say 3 times a number?
No, it's just negative.
No, it
So
doesn't.
now we go to times, right? We go to times. That's the next thing after 3, right? So how do I draw times? What can I draw? What symbol denotes multiplication?
The dot.
Parentheses.
I could do a dot or I could do parentheses, right? I'm gonna do the parentheses because I don't know what's gonna come after the times. Now let's keep reading. What's gonna happen after the times? What are we timesing? The what?
The difference of a number.
And
So 11.
so when we find the difference of two things, what operation is difference?
Subtract.
Subtraction. So if I told you, hey guys, what's the difference between 20 and 11? You would do what? If I told you find me the difference of 20 and 11.
20 minus 11.
20 minus 11. You're right. But this doesn't want us to find the difference of 20 and 11. It wants us to find the difference of what?
X minus 11.
Correct. And we're done. Does their color coding help or confuse? Let me
Help.
let me go ahead and show you what I mean by color. So that's the 3, right? We know the times is the parentheses, and we know that the difference is the inside right here. Is everyone with me with B now? Because you're gonna try one on your own.
Yes.
All right, let's look at C
Because
class. Go ahead. I'm sorry.
from like the words to the actual like the way you write it down,
Expression, it's an expression, yeah.
it makes a big difference.
It does make
It's like
a difference.
it's less complicated.
Now, my question is, after we wrote it and we highlighted, do you see the connection from the words to the actual math symbols now?
Yes.
Okay, good. That's the key here, is can y'all make the connection to these words to the English symbols? Let's look at C class, the quotient of 5 times a number and 11. The quotient of, right? So we know quotient is gonna be a division problem. What's gonna be on top? Remember, it's the first word after what letter of word? It's after of, right? So this
Yes.
part is gonna be what? The orange is gonna be what? The top or the bottom?
The top.
Top.
Good. And then after the end is the what?
The 17.
Bottom.
The top or the bottom?
So it's 5x divided by 17.
Money, that's correct. Do you have any questions before I throw you into the practice problems, guys? Any questions on the steps we took? All right, let's see how you guys do. I'm gonna go ahead and give you guys 4 minutes on this one. Good luck. And feel free to ask questions, guys, to me or to your classmates or to your tutor. Like yeah, I don't mind y'all discussing the work, guys. Like there's no taboo. Like I ain't gonna judge and be like, oh, nice. You can annotate. How'd you do that, Jacob? Are you on your phone or your computer?
On my phone. I was just like trying to read through the problem. And I didn't mean to do that. My bad.
No. Like I can call on people to write. That's all. That's all you showed me.
Oh, fuck.
But it was on your phone, so people on their phones can write. Fancy. Don't worry, because we're in person next week, class. So don't worry, like we're good. Y'all got my email about the classroom that we're in and everything?
Yes.
Good, good, good.
So I feel like I should like go on a tour before the school day.
What was that?
I feel like I should go to the school and get a tour and find my classes.
I definitely recommend you do that, dude. If you once you have your schedule for where your buildings are at for Monday through Thursday or whatever days you'll be there, I would go. Because I went last week actually to look where they're at, the buildings, and because I want to go get my ID and parking permit. You know, professors have to pay to park on campus. Like, kind of. I know I'm being recorded, but so I'm gonna be careful. But
Kind of messed up.
yeah, dude, for real. It's like, yeah, work for me, but pay to park here. Like, that's toxic. But whatever. All right. Anyone have any um thoughts on A? Anyone want to share what they think they got? I'm ready.
I can't. I mean, I haven't got anything. I don't
No, you haven't got any for A?
know.
I actually went
No.
backwards myself. So I did get C and B.
So what'd you get for
Well,
C?
For C, I got 39 over 2x.
Okay. Anyone agree or disagree with that C?
Agree.
I agree.
You are correct on C. Anyone want to share what they got for B?
Twice.
So
I
break it down.
got,
Go ahead.
oh, I got 2 plus X plus 3.
2 plus X plus 3.
What if it's 2 and then parentheses X plus 3?
Like this. Why are you saying 2 parentheses? What's the key word that's telling you that, making you do that?
Twice.
Twice. And then, yeah, you're right. The twice is the multiplication part. And then the sum of a number and 3 means we're doing what?
X plus 3.
X plus 3. Yeah, you're right. Do you see that, Sophia? Because you have put 2 plus X plus 3, right, ma'am?
Yes.
Now, if it had started off with the sum of 2 and a number and 3, if the sum was before all of these things, then yes, you would be correct. But remember that twice is actually a multiplication phrase, okay?
Oh, okay.
So
I don't like the way they did that.
yeah, it's kind of slimy, right? You gotta stay on your toes, guys. Mathematicians and mathematics textbooks, they like to like be tricky. Like, so stay on your toes, all right? Look at A, guys. The product of 5 and a number is being decreased by 25. So
So is
first,
that 5x
that's 5x, right? Right? Why are you saying 5x? What's the key word there?
of
Of. So it's 5x. So it was a product of 5.
minus 25
Why minus?
decreased by?
And you're good. Yeah, you're done.
Bro, what the fuck?
Any questions on what we did, guys? All right. All right, and we're done with 3.2 class. We're done. Just because of timing, I know normally I do give a break, guys, but I do want to stay on top of this. So let's go ahead and move on to the next lecture. So we're doing 3.3. Just due to time, I won't be able to give a break. Just because remember, we are trying to just catch up so we can just use class time next week to just review and work on our assignments. So 3.3 is solving linear equations in one variable. The reason why there is a definition on there is because you will see this definition word in the homework for 3.3. So I know sometimes it gets tedious of writing the stuff that I have on the slides, but it is for your benefit, guys. I'm not doing this because I want to torture you, but just to prepare you for what you're gonna face.
I mean, it could have been worse. You couldn't have not given it to us.
Exactly. And that's been me, like I've had homework assignments where the questions were nothing like the notes. And I'm like, dude, like what's going on? Like, why'd you show us these things if it's not on the like the homework?
Is it 5?
Oh, did you already solve it?
Yeah. Oh, not supposed to.
If you know, dude, if you no, you would never be told not to do any.
Oh, I didn't even know there was a. I didn't even know there was a definition.
There you go. Now that you solve this, go ahead and write the definition somewhere so you can have it, because you will see this in the homework as a question. All right. So let me go ahead and jump into the equation. So we're gonna solve it, right? So I'm gonna draw down the line down the equal sign, right? Now, class, before I can move things around, can I combine any like terms on the left side or the right side?
No.
No, right? So at that point, we can start to manipulate to move things around. Now, remember, the objective is to move all the variable terms, everything with the letter to one side and all the numbers to the other. So can someone give me one first step you took or you would take to get A by itself? There's more than one first step, guys. What is something you can do to start getting A by itself?
You subtract it, right?
Subtract what, sir?
1, because since it would typically go in there for A.
So you'll subtract the A?
Yeah.
So it'd be
Yeah.
negative 8. When we do to one side, we have to do to the other. Where will we put this negative 8? Under
Here
the
on
B
the
or the
left
six?
side,
Where in the left side?
under 3A.
That's correct. That cancels out. What's
Oh,
3A?
I
Go ahead.
I did the -6 first.
Now let's see if we get a different answer from you. Since you did a different first step, let's see if our answer is different. So 3A minus A is 2A. Bring down the -6 and bring down the 4. Now, what will be the next step in getting A alone now?
Always subtract, so you'd add.
We would add the 6, so we're subtracting originally. That cancels out. And then we get 2A equals 4 plus 6, which is 10. And now to finish this off, what's the opposite of what's happening? What's happening with 2 and A? They're being what?
Cancel that, or wait, no, you're, you have to excuse me. I'm thinking
No,
of
you're
the
fine.
term.
We divide to
Divide.
cancel.
Right, there we go.
And what's 10 divided by 2?
5.
Is that what you
Oh,
got?
I got the same answer.
Excellent. So what does that tell us? That tells us that we can solve an equation differently, but still get the correct or the same answer. So that tells us, is there just only one way to solve?
No, there's multiple ways.
Multiple. Okay. So my thing isn't for me to show you my way. There isn't just a my way to solve. There's actually any way. The goal is, can you get the same answer? Are you manipulating it correctly? So let's go ahead and we will check it, right? 3 times 5 is 15. 15 minus 6 is 9. 5 plus 4 is 9. So this is true. It works out. Go ahead and practice this problem on your own, guys. I'm gonna go ahead and give you guys 2 minutes on this equation. Good luck. Remember to look at the steps that I took. I'm not saying they're the same, but they may help you. And feel free to ask for questions, guys. Like if you're stuck, don't need help moving along, let me know. Like this is a class, this is lecture. This is where we can on practice, you can talk it out. I already kind of have the answer in mind. Let me know what you guys think.
I kind of have at least the steps down.
Did you get your answer?
Not quite yet, but I'm getting there.
Good, good, good. That's what matters. Now, a little technique for you guys, in case we never have time to go over a certain problem because of timing, always put a star by the practice problem, so that way you can either ask the tutor for help, or when you make a session with them. All right, anyone have a solution for this practice problem?
-4.
X equals -4. Does anyone agree or disagree with the x equals -4?
I got -4.
Good, good, good. So if you got -4, you're on the right track, class. Are there any questions on this equation before I move on, class? Any questions at all? All right, I'm gonna go ahead and move on. I'm gonna give you guys a minute to copy this down before I solve it. There's an example too for today's lesson. As you notice, is the equations are getting a little bit more trickier. All right, guys, let's go ahead and take a look. So first things first, draw the line down the equal sign. All right, are there any like terms that I can combine on the left-hand side, class?
17 and 3.
What's 17 plus 3?
8.
That's 20, right? Am I right about that? 27 plus 3. All right, what about the right side, class? Any like terms on the right side?
-3x.
What's -3x take away 3x?
-6x.
-6x. Bring down the plus 21. Now we have to manipulate this to get x's alone. So remember, there's more than one way to do this. I'm gonna do the way I know. There's more than one way, but I'm gonna add the 6x, right, to get x alone. I'm gonna move it over here. You owe the bank 7, but I was able to give them 6, so I still owe them 1. Bring down the plus 20 equals
Got
21. What'd you get?
-1.
All right, let's see if I match with you. So then I get -1x equals 1. Divide both sides by -1. So I get x equals -1. Good job, yeah. And then you check your solution by plugging it in. So then you'll check. I'm just gonna do the first step. It's gonna be 17 minus -7 times -1 plus 3 equals question mark -3 times -1 plus 21 minus 3 times -1, which actually gives us 17 plus 7 plus 3, which is 27 plus equals 27. So that's true. All right. Any questions, guys, on the steps that I took here, guys? Any questions at all? All right, let's see how you guys do on this practice problem. Let me go ahead and give y'all 2 minutes on this, or I'll give y'all 3. No, 2 minutes. I'll add more if I need more time.
Was the answer -1 for the other one?
Yes, sir. Yes, it was.
I don't think I did it right.
All right, well, talk me through it. What'd you do on the left side? What were you able to simplify, sir?
40 and a 5.
What'd you get when
So
you
I-
do that?
45.
So 45 minus 5y, right? Because then nothing changes there. What about the right side,
Yeah.
sir?
So the -2 and the -4, so that's -6. Why?
Bring
Right? Or
Yeah,
or
Then we bring down the -10, right? Because there's nothing to mess with that.
yeah.
All right, so what will be next, sir?
Let's see. So you can do the ones without the variables.
All right, so what would you move? How would you move? And
The 45 to the
How?
-10.
How would you
So
move?
minus 45.
Good. And then with the -10, right? Because they're both constants. Good, good, good. Bring down the -5y, right? And the -6y. What's -10 take away 45?
And that -55.
-55, that's correct. We're not done yet, so what's next?
The 6. You gotta get it. You gotta remove it. So +6. And then that's -1.
You
No,
sure?
wait. +1. My bad.
+1y, right? Equals -55.
-55.
And 1y is the same thing as what?
Why?
So we are technically what?
None.
There
Okay.
you go. Is that what you did? That's what you got?
Yeah.
Good job. Yeah, that's good. Anyone agree or disagree, guys? Anyone like got something different or did something different? All right.
So I thought that was funny
What part?
when he said why after you said why. Like why am I doing this? You know?
Yeah, yeah. Nice. All right, guys, example 3. So after seeing different types of equations, like more challenging ones, are y'all able to like understand when you see it, are you able to see, oh, this is what I can do. I can simplify this. I can't do that. Yeah, are y'all able to like put everything that we've been learning together? Has that been okay for y'all, or is that something you're still struggling with? I just hope I'm exposing you guys enough, like I'm. All right, I'll give you a minute to write this one down before we jump in. All right, that's the timer, guys. So now the first thing we're gonna do on the left-hand side, remember the property, we can distribute the 7. 7 times x is 7x, 7 times -2 is -14. Bring down the 9x minus 6. At this point now, we use algebra to get x's on one side, numbers on the other. So I'm gonna move this variable term 9x, by the opposite of 9x is -9x. Do that on both sides, right, to keep it the same. 7 take away 9 is -2x. Bring down the -14 equals -6. Now remember, we want to get x alone. So since we move x's to the left, I'm going to move constants to the right. So the opposite of -14 is +14. So again, -2x equals, I owe the bank 6, but I gave them 14. So I have 8 for myself. I'm gonna divide by -2 because they're being multiplied, and 8 divided by -2 is -4. And we are done. Now it wants us to check. So to check, you just plug it into your original equation, guys. So it'll be 7 parentheses -4 minus 2 equals question mark 9 times -4 minus 6. -4 minus 2 is -6. -6 times 7 is -42. 9 times -4 is -36. Minus 6 is just -42, which is true. So this is the correct solution. All right. Any questions on the steps that I took to solve this equation, class? Any questions at all? All right, if there's no questions, guys, and then if I didn't give you enough time to think of one, if you think of one, you can always unmute and ask me to go back, or you can type it in the chat, all right? Here is the next practice problem, guys. I'm gonna go ahead and give you guys 2 minutes, and I'll add more time if you need it. How's everyone doing with this one? Anyone running into trouble, have any questions? All right, anyone have a solution for this one or need more time to solve?
17.
Got A equals 17? Anyone agree or disagree? Excellent. All right, good job, Justin. Good job. This is correct. A equals 17 is correct. All right, let's go ahead and move on. Now, in case you're probably wondering, all right, well, what steps do I need to do to solve this? Like if I'm confused, I went ahead and got these steps for you from a resource. So I'm going to give you guys about 4 minutes to copy these things down. And while you do that, I'm gonna go get myself another bottle of water. Are you guys liking these steps the way they're written out? So that way, like a recipe checklist for future problems, right? It's pretty much the process we've been doing, right?
Yeah, I've been screenshotting since you gave permission for that and just printing them.
There you go, sir. All right, class. Does anyone need more time for this slide or for these steps?
Yeah, just like 2 more minutes.
All right,
Yeah, me
we're-
too.
All right, adding 2 more minutes to the timer.
I'm done.
All right, you good? Everyone else good? All right, since no one said any more time, I'm gonna go ahead and move on. Example 4. Give you guys a minute to copy this down, and then we'll get started on it. All right. What's the first property? As if you're writing this down and you're looking at it, what do you think is the first thing we're gonna have to do is to be able to solve this equation, guys?
Tribute.
Distribute the
Correct,
property.
dude. Yes, distribute. Only 2 arrows, right? Because only what's inside the parentheses. So then 3 times 2x is 6x. 3 times minus 6 is negative 18. Plus 6 equals 0. What's next, class? After I do that,
Combine like terms.
what can I combine?
18 and 6.
Yeah, negative 18 and 6. I owe the bank 18, gave them 6, so I still owe them 12 equals 0. Now I gotta solve for x, right? So what do I move over to get x alone? Gotta move the 12. The opposite of minus 12 is plus 12. So I get 6x equals 12, divide by 6, and I get x equals 2. And I'm done. It just want us to check, so then the check, plug it into the original. So it'll be 3 parentheses, 2 times 2 minus 6 plus 6 equals 0 question mark. 2 times 2 is 4, so it's 4 minus 6. 4 minus 6 is negative 2. 3 times negative 2 is negative 6 plus 6, which is 0, which equals 0. Which is true. If your zeros look like O's, always draw a line through them to know that they're zeros. That's the difference. If you don't know how to draw like a 0 to an O, always draw a line through it. That makes it a 0. All right. Any questions on this example before I move on? Anyone need more time to copy this down before I move forward? I hope you're letting me know, guys. Remember, I'm not sidekick. If you need more time on things, just all you gotta do is just ask. And then worst case scenario, I'll just say, take a picture, screenshot it, or whatever. All right. Here is your practice problem, guys. I'm gonna go ahead and give y'all 2 minutes on this one. Good luck.
Sir, is there like a phrase or a statement when x is equal to 0 or no?
No, sir. No, sir. X equals 0 is just like any other solution. X equals 1, X equals 5. It just so happened to be the solution is a number that has no value, you know?
Yeah. Okay. I got 0.
Good, good. X equals 0. Anyone agree or disagree? Anyone want to talk about the steps? Anyone need help on the steps? Speak now, forever hold your truth.
I agree.
Okay, cool. Good. You are correct. If you got x equals 0, good job, guys. And you can even check it out. Yeah, let's see if y'all can check it with in your head. So we'll do x is 0, right? So that the first thing we would do is 0 plus what? 3, which is 3. Then we will multiply that to what? To 4, which is 12. Add 1 to 12, which is 13. So it's true. All right, let's move on. All right, I'm gonna go ahead and give you guys about 4 minutes or 5 minutes to write down the chart and the example. Now, you know how we wrote algebraic expressions in the past? This wants us to write numerical sentences as equations now. We're not writing expressions anymore. Now we're writing equations. So go ahead and I'll give y'all 5 minutes to write this new chart. So this is a second chart we have now. The first one was for the keywords for operations. This is the keywords for equal signs. All right, the timer's almost up, but before I jump into the example, does everyone see how the keywords and phrases of equals could be into an expression uh before it's into symbols, like the way like 3 equals 2 plus 1, or the quotient of 10 and -5 gives -2? Just realizing that those keywords symbolize equal sign. Like for A, example 5A, the product of 7 and 6 is 42. So is the keyword here, is equal to is the keyword here, and yields is a keyword here. So for the first one, A, the product of 7 and 6, so product is 7 times 6 is equal sign 42. That's true, right? 7 times 6 is 42. Yeah, that's correct. B, twice the sum. So twice the sum of what? The sum of 3 plus 5 is equal to 16. Well, 3 plus 5 is 8. 8 times 2 is 16. So we're good. The quotient of -45 and 5, that's top and bottom. -45 over 5 is yields to -9. And that's true. And we're done. All right, anyone have any questions on what I did in these examples, guys? Any questions whatsoever?
Why does equal matter in the equation?
Like where it's at, or you're talking about like the different phrases? What is?
Yeah, where it's at, and like both. Like, how does
Um,
it apply?
well, the different variables, the different keywords is just that, you know how multiple things can mean the same thing. That's what the different keywords are. Mathematicians have established that these keywords could symbolize equal sign. Now, where it's at, you want to make sure that the words translate into a math symbols that is true. Okay, like for example, I don't want to say the product of 7 and 6 is 42. So it would be right to write the product of 7 times 6 and 42, without the equal sign. So this is not right or true, So the key to this is you want to be able to look at it at a sentence and say, all right, I gotta make an equation that produces a true statement. That is a key to writing sentences into equations. So let's have you give it a try with this practice. This is the last practice of the day, guys. I'm going to give y'all 5 minutes. The key here is you want to write an equation. So something equals something, a left side equals a right side, and you have to make sure the things that you put in from the sentence make it a true statement. That is the objective here. That is what the end goal, the end game. That's what you want to be able to do. So I'll read practice 5. So translate each sentence into an equation. A, the difference of 110 and 80 is 30. B, the product of 3 and the sum of -9 and 11 amounts to 6. The quotient of 24 and -6 yields -4. And if anyone wants to share their answers for any of them, feel free to unmute and just let me know what you put. It doesn't have to be in order. You can give me C, you can give me A, you can give me B. I'll tell you right now, C is the easiest, A is medium, and I would say B is the most challenging one. But they're not impossible though. Just break it down, reread it until it clicks in your head. Has anyone figured out any of them? A, B, or C?
For A, I got 110 minus 80 equals 30. And then for B, I think I think I got it. It's 3 parentheses -9 plus 11 close the parentheses equals 6. And then for the C, I got 24 divided by -6 equals -4.
Interesting. All right. Appreciate you for sharing. Anyone want to disagree or agree with any of them?
I agree with all.
Excellent, Sophia. If you've agreed with all three, oh, didn't mean to draw a line through that. If you agreed with all, oh, damn it. They're all right. I was gonna box them, but clearly I cannot draw a box today. Yeah, guys, if you got these three answers, you're on the right track of converting sentences into equations. All right. So that does conclude the lecture, guys. I'm gonna go ahead and stop recording.